Start here. So, let's see. Where do I want to start? I don't know. Let's get some background out of the way. If we have 4 to the power of 2, just like we mentioned, 4 is called our base, and 2 is called our exponent, also called power. We really want to make sure we know what that 4 is called, because once we move through to like 2.1 B, C, and D, we're going to be talking about like bases a lot. So know that the base is the big number, B, base, big, and then our exponent is, of course, that little tiny number on the top. All right, let's start with 0 exponents, shall we? Where's my quiz? There we go. Everybody writes at their own pace. I've been told I'm a fairly fast writer, and the reason why is because I know what I'm writing and you guys don't know what's coming, right? So I'll, of course, pause as we go through. If you feel like I'm going way too fast, by all means, raise your hand and ask me to slow down, okay? I want to make sure I'm not skipping over anything and you guys have enough time to write. So I'm going to write down this little sentence here, and then you guys will have plenty of time to copy it down, okay? Nice and simple. Can I get a volunteer for a rich ticket to read out this 0 exponent definition? Let's go Osase. Go for it, sir.
Any
number, sorry.
Any number raised to the power of 0 is equal to 1.
Beautiful, thank you, sir. Any number raised to the power of 0 is equal to 1. All right? Any number at all. For example, if we have 5 to the power of 0, if you've never seen 0 written with a slash through it, it's so you know that it's not an O. That's how I write my zeros. Five to the power of 0 is going to be equal to, anyone want to take a guess?
0.
Devin?
5.
5? Let's read the definition again. Any number raised to the power of 0 is equal to?
1.
What's that? Okay, that's all right. Maybe that was too early to ask a question. That's all right. Any number raised to the power of 0 is equal to 1. 5 to the power of 0 is equal to? 1. Okay? I know that's a little confusing based on what we know about exponents. We could, spend 15 minutes talking about why it's equal to 1, but you don't need to know why. All you need to know is when you see a 0 exponent, the answer will be 1. Okay, let's try a second example. If we have 1,567 to the power of 0, anyone want to take a guess at what that is equal to? Devin, you want to redeem yourself? Go for it. 1, there we go. 1, exactly right. That's why I underline the word any before number. Doesn't matter how big, how small, positive or negative, if it's raised to the power of 0, it is equal to 1 every single time. Yeah?
If it's a negative, will it be like a negative 1 or will it always stay at 1?
It will always, so you're saying if it was like negative 5 to the power of 0, equal to 1. Not negative 1, 1. That's a good point. Let's add in that third example. If we have negative 2 to the power of 0, You may think that would be equal to -1, but it's not. It's just equal to 1. So big, small, positive, negative. If it's raised to the power of 0, it's equal to 1. Give me a thumbs up if that at least not necessarily makes sense, but if you get what I'm trying to say. Okay, good. It's really that simple. Don't overthink it. Anytime you see a 0 exponent, boom, the answer is 1 right away. Okay? Now let's do negative exponents. Negative exponents. I'm a big fan of using step-by-step instructions to solve problems in this class. So, we're going to go through 4 steps to solve negative exponents. Let's say that we've got something like, I'll do 5 to the power of -2. That's a little bit different from what we've seen. 5 to the power of -2. Yes? Good. That's a great guess. Thinking it might be -5 times -5, but that would just be 25, right? What's up? 125? That's another great guess. But this process is a little weird. I love you guys having intuition and assuming. That's great. I love it. Let's break down these steps because it will get, unfortunately, a little bit complicated. Step number 1. Okay, step number 1. Turn your base into a fraction. Turn your base into a fraction. If needed. Like we saw in the warm-up, sometimes our base will be a fraction. Turn your base into a fraction if needed. Step 2, you're going to flip the numerator and the denominator. So your numerator, the number on top of your fraction, goes to the bottom. Denominator, the number on the bottom of your fraction, comes up to the top. And we'll see what this looks like in a second. We just want to get the steps down first. Welcome, good morning, Delaren. Step 3. Make the exponent positive. Do you have your notebook, Delaren? Okay, go ahead and get it out, and then I'll get you caught up here in a minute. And finally, step number 4, evaluate or solve the exponent. Which is what we did in our warm-up. We evaluated exponents. So if we have 5 to the -2, let's take this step by step. I'm going to move this down. If we have 5 to the power of -2, what does step 1 say we have to do?
Turn
Turn your base into a fraction. What's my base in this problem? 5. How can we turn 5 into a fraction without changing the number itself? Put it over 1. Good. I heard a couple people say it. We're going to put it over 1, just like that. How are we feeling with step 1? Not too bad? Okay. Step 2. We're going to flip the numerator and the denominator. So our new fraction is going to look a little different. What's my numerator here going to be? 1. What's up? You don't have a what? A notebook? Okay. So if the 1 on the bottom came to the top, what's going to be on the bottom now? 5. What's attached to that 5 though?
Power 2.
The negative 2. That's right. The power of negative 2. So all we did here was flip our fraction around. Anyone remember what that's called when we do that? It's called taking the, starts with an R. Reciprocal. Good, exactly. I heard a couple people say it. I don't want to confuse you with that term, but if we know it, great. Flipping a fraction around is called taking the reciprocal. Don't worry about that. All you got to do is flip them. Do you have a pencil? Okay. So I would probably leave this top blank and then start with the steps right here. I'll give you my notebook after so you can fill them in, okay?
I use it now.
Not during this.
Well, after this.
Yeah, once we get through. Step 3 is making the exponent positive. So we're going to keep our fraction the same, 1 over 5. But what's my new exponent going to be?
2.
Just 2, right? Positive 2. Step 3 is make the exponent positive. So all we changed from step 2 to 3 is negative 2 to positive 2. Step 4 is evaluate the exponent. And what that means is we're going to get rid of this exponent by solving. So the 1 stays on the top, just the same. But what's 5 to the power of 2 equal to? 5 times 5, exactly. 5 times 5, which is equal to, from our warm-up, we remember, 25. Wait, that wasn't in the warm-up, my bad. But yes, 25. And that is our final answer. So I love how our guesses at the beginning, Devin said the answer might be 25. Hope said 125.
I thought it was 5 to the power of 3.
Oh, I see. My bad. Yeah. Very close. But, hey, good morning, Ashley. You guys were both really close because we do have a 1 and a 25, but it's in a fraction, so it's a little bit weird, right? Thank you. Do you have your notebook today, by chance? If not, you can just use.
Oh, yeah, I bought it.
Okay, perfect. 1 over 25 is our answer. So think about it. What would the answer to 5 to the power of positive 2 be? 25. So 5 to the power of negative 2 is just 1 over that. 1 over 25. Okay? Might not make a whole lot of sense now. We're going to do a couple examples before we get our worksheet. And then we have what? Like half an hour to work? It's plenty of time. So I'm going to bring this down. Let's see, what do I want to do? Okay. For example, if we have, let's do two to the power of negative 3. 2 to the power of negative 3. What's the first thing that we're going to do here? Devin, what are we going to do first?
Flip the numerator and
Good. Flip the numerator and the denominator. I don't see a numerator and denominator yet. What do we have to do before that? Namanpreet? Put a 1 underneath. Step 1, turn your base into a fraction. There is no fraction here, so that's what we have to do first. Great job, you guys. Devin, you got step 2, though, right? We put it over 1. And then what do we do with that fraction now, Devin? We flip it, right? The top comes to the bottom goes to the top. I'm going to move this up so those in the back can see. So my 1 is now on top. My 2 to the negative 3 is now on bottom. What's my step 3? Jaron? Make your exponent positive. That's right. 1 over 2 to the power of 3. How can we expand out 2 to the power of 3? What's that going to look like? 2 times 2 times 2. Exactly. What is 2 times 2 times 2? Final step, evaluate. Kamora?
16.
16? Very close. Wait. Very close. I think 16 would be 2 to the power of 4.
6. 8.
6 is close. I heard a couple people say 8 right here in the front. 2 times 2 is 4, and then 4 times 2 gives us that 8. Great job. What's my final answer here? 1/8. 1 over 8. And again, if we had a positive exponent to start, our answer would have just been 8. Just like in this other example, our answer would have just been 25. Okay? And Ashley, I'm going to make sure you get the notes beforehand in a bit, okay? I think I want to do one more example. Now let's say we've got something like this. Sorry, are there any questions I can answer about those first two?
No.
Give me a thumbs up if you're kind of following this 4-step process. Good, 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 good. Fellas, we following over here? Yeah? Okay, awesome. Just want to make sure. I didn't see any thumbs. Last example of the notes. Let's say we've got 1 over 3 to the power of negative 2. I'm going to move this down again. 1 over 3 to the power of negative 2. Now, what is my base in this problem? 1 over 3, right? The whole fraction is our base because the exponent is attached to the whole fraction. So my step 1 says turn your base into a fraction if needed. Do we need to here? No, it's already a fraction, right? So we skip step 1, jump right to step 2, which would be to do what? Flip our numerator and our denominator, right? So now what we have is 3 over 1 to the power of negative 2. We want to make sure that our exponent stays on the outside of those parentheses, and we're just flipping the actual fraction inside those parentheses, right? That was step 2, right? Sorry, I forgot to put the little step numbers on that blue example, but there they are. What's my step 3 going to be? Make the exponent positive. 3 over 1 to the power of positive 2. Hopefully you guys are seeing where this is going. That was our step 3. Now, how can we write 3 over 1 so that it's a little easier on the eyes? 3 over 1. How can we write that so that there's a little bit less going on? Just 3, right? 3 over 1 is just 3. So now we have 3 to the power of 2. My step 4 is going to be evaluate that exponent. So 3 times 3, which equals 9. That's right. Yeah. Make sure you sign out and take the green test. How we feeling? Show a thumbs up if we're feeling really good, ready to go. Sideways if there may be still a question or two lurking in your mind, and thumbs down if you're like, I have no idea what we just talked about. And that's fine too. I see lots of thumbs up. I see some thumbs sideways. Okay, perfect. Let's get some practice going with worksheet 3. Those of you who came in a little bit late, I'm going to make sure you get these notes so that you can copy them down in the time we have. We do have, like 23 minutes? That's a bunch of time. And we'll just get right into it. Yes? Sure. Yep, that's fine. Let me stop this recording.